Now we're doing section 9.5, which is called applications, which is just a fancy name for word problems. So we have a triangle here. The height is h, the base is 2h plus 4, and the area of the triangle is 120. We want to find the measure of the height and the measure of the base. So what do we know? We know that the area of a triangle is 1/2 base times height, which means 120 equals 1/2 times 2h plus 4 times h. Now this may not look it, but this is actually a quadratic equation. Let's simplify it a little bit. So let's see. I'm multiplying both sides by 2 to bring the fraction over here, distributing out the parentheses, bring everything over to one side, dividing everything by 2 to make the number smaller because I have a common factor or whatever. And I have h squared plus 2h minus 120 equals 0. Now I could solve this with the quadratic formula, or I could solve it by factoring. I'm just going to do factoring because it's very simple. So I get here h equals h plus 12 times h minus 10 equals 0. H equals negative 12 or h equals positive 10. I'm going to reject h equals negative 12 because, again, if this was a pure algebraic equation, negative 12 would be a good answer. But this is a physical problem. We have a physical triangle, so I can't have a negative value for h. Anyway, if h is equal to 10, that means that the height equals 10 and the base equals 24. How did I get 24? I plugged 10 into 2h plus 4, and I got 24. Here's another example. We have a rectangle whose area is 150. The width is w. The length is 3w minus 1. Sometimes it'll say that the length is 1 less than 3 times the width. It's another way of saying that. And we want to find the length and the width of this rectangle. Well, area equals length times width, so that means w times 3w minus 1 equals 150. And now I just distributed out the parentheses, and I brought the 150 over to the other side. And this really can't be factored, so we're going to have to use quadratic formula. So w is equal to 1 plus or minus square root of 1 plus 1800 over 6. Again, that's just coming straight from the quadratic formula. 1 plus minus rad 1801 over 6, and that is not 1 but 2 answers. When I do plus, I get 7.2. When I do the minus, I get negative 6.9. And again, if this was just a pure algebra equation, I would have 2 answers. However, this is a physical rectangle, so I need to reject the negative solution, and that's my answer right there. That the width is 7.2, and the height and the length. The width is 7.2, which is my w, and the height is 20.7, which is just 3w minus 1. 3 times 7.2, and then subtract 1, you get 20.6, and that is my rectangle. So here's something which I always liked: fireworks. We have a firework is shot straight up in the air, and the initial velocity is 130 feet per second. Because as it goes up, the velocity changes. It kind of slows down. Gravity makes it slow down. But when it shoots out of that cannon or whatever, it's going at 130 feet per second. And eventually it's going to reach a height of 260. And the question is, how long will that take? How long will it take to reach to solve this? We use an equation for this case. Height is equal to negative 16 t squared. The negative 16 comes from the force of gravity, times v0, that's the initial velocity, times time. And all I'm going to do is plug in the height. I want the height to be equal to 260. V0 is going to be 130. And I want to solve for t because I want to know how long is it going to take. Well, making these plugins gives me this quadratic equation right here. And now I just make things look nicer, and I get this. But I could have divided everything by 2. I just didn't bother. Sorry, it doesn't matter. It'll still work in the quadratic formula. So I get t is equal to 130 plus or minus the square root of 130 squared minus 4 times 16 times 260. I'm following the ABC of quadratic formula. 2 times over 2a, which is 2 times 16. And if you crunch out the quadratic formula, you get t is equal to 4.6 seconds and 3.6 seconds. So how can it be both? What is it? Just gets up there. Well, how is that possible? Well, it means that it goes up in the air at 3.6 seconds, it hits 260. It keeps going up, and then it comes down again. And then at 4.6 seconds, it hits 260 again. So there are indeed 2 times. So on the way up, after 3.6 seconds, it's still on the way up, and it hits 260. And then it comes down, and after 4.6 seconds, it's again at 260. And that's how you get 2 answers. Which, by the way, symmetry tells us that it's going to hit the height at the halfway point of these 2 guys, which is roughly 4.1 seconds. That's symmetry. Yay!